Hey, and welcome back to Gaming for Tokens. In this episode, I'm going to hopefully pick up where I left off in the last video. But first, I want to apologize for not meeting any video deadlines, personal video deadlines for myself here. Kind of been MIA for a little while. My life is kind of exploding at the moment. I apologize for that, but I'm hoping to kind of finagle some recording time in here and there now that my life is kind of settling down and becoming more regular again. So in the last video we talked about the AI variables, all of the variables that I wrote, which was kind of a terrible place to just kind of cliffhanger you guys. I did change one of the variables. I changed a very, very important few variables that I will get into why and what I changed when the time comes. It has to do with the line of sight cones. Those are really broken. And also worth noting, I actually have recorded this video twice already, I think, but both times the video ended up, how do I say this? It ended up really terrible. I fumbled around a lot more than I had liked because there were bugs in the code that I hadn't fixed and that I found during the video and stuff like that. So I don't know all of what I've covered and what I haven't, but because of the gap in videos, hopefully this will be better than it could have been otherwise, which will be weird. But anyway, kind of jumping right in, I'm going to go ahead and open up MonoDevelop. I already have it open, but I'm going to bring it up. So, yeah, we talked about what all of these, well, I don't know, how do I want to do this? How do I want to do this? That's okay, I guess. It's just bright. Talked about all these variables and all these different classes and kind of what they do, and where I'm going to go with that is I'm going to start at the start function and just work my way through what a single frame of calculations would be and what all the different possibilities would be in that frame. So, for example, on start, we're going to set the base health. If you remember back to the previous video, the reason why we're doing that is so that we can do comparisons for percentages later on. So the current health is going to be equal to the base health. Instead of modifying the base health, we're going to modify this current health variable and then compare that against the base to get a percentage back, so we know how much health we should have and how much health we don't have. The next thing we're going to do is we're going to grab that nav mesh agent, we're going to store it so we can access it later, because we're going to be accessing it quite a lot in this thing to get positions, set positions, and find out where our destinations are and all that jazz. And then we're going to set our destination to our current position. The reason why we're going to do that is because the way that the systems work, basically when you arrive at a destination, it will automatically start triggering some behaviors. Instead of actually just manually triggering those behaviors and kind of making it brute forcey, I kind of use this to not only test the system but also initialize the system in kind of the same function call by just setting the position to our position, and then we know that we will we know that we're at a destination and we need to immediately start running the behaviors that we need to run when that happens. Yeah, I don't know. You'll kind of see why that's the thing later on, and maybe if I remember, I'll go back and reference that. The next thing I'm going to do is set my base speed to the speed of the nav mesh agent. That way, the nav mesh agent speed variable, you should remember, down here, the speed variable down here controls the speed that our AI moves in the behaviors as well. So we have control over this speed, or this speed with this variable. Kind of a nice little thing so that we don't have redundant speed variables. Like, I could have put a public speed variable in this script to be able to set, but there's already one on the nav mesh agent, so why not just piggyback off of that one? It's kind of my mentality. And then we get to our first function call, gather targets. And gather targets is a pretty simple function call. It's all the way at the bottom here, right here, target gathering. Which, I don't know if I've talked about this or not in videos before, but I use this tab system. This is kind of like my own thing that I came up with in college for discerning where things were. It's just it's just a comment with underscore dash over and over and over again, and then the name of something on the right. That way when I'm cycling through things, I can just I see it and I can stop and I can read what it says, so I know where I am in my code. I don't know if I've talked about that or not in this video, but it was really handy for me and my programming instructor at the time. Thought it was really clever for digging through long scripts of code, especially complicated ones where everything kind of starts to look the same, like it's a big wall of text eventually. That kind of breaks it up a little. Anyway, kind of just a visual aside tip thing. I don't know what you want to call it. So anyway, our gather functions function, our gather targets function, that's what I wanted to say. The purpose of this function is to gather every other AI in the scene. In a large game, this would be a really bad thing, but in the purposes of my example, where there's only 4 AI, it's probably okay. You'll get into maybe some trouble when you have like maybe 20, 30 AI, and every time an AI spawns, you're gathering those 20 or 30 AI on that AI, because then it gets kind of mayhemy, and you end up with a lot of things stored on a lot of things, and that's not necessarily what you want sometimes. But for the purposes of this demo, this works great, and it does what I need. A better way to go about this, if you have more enemies, is to have a central script that is your AI manager that houses all of the AIs in different lists, and then you can just access them through that. That way they're all stored in one place, and you can kind of reach in and read what you need to read off of it and then go back. If that doesn't make sense to you, I'm sorry. I'm going to say some stuff during this that might not make sense to some people, and I mean, in the effort of making this video not 5 hours long, I'm going to kind of keep chugging along and explain what I did and give you tips for how to grow from here, but I'm not going to really explain those tips. Sorry. So gathering targets. The first thing we got to do is we got to make a game object list that will encompass all of the AI in the scene. And the AI in our scene, if set up properly, should be tagged with AI. They could be tagged with whatever you want them to be tagged with. I tagged mine with AI. So we want to house all of those in this list, which is what this line does. By doing that, we now know how many there are, and we can then filter those into the appropriate lists as needed. So we're going to go in a for loop here, and we're going to say, hey, do you... we're going to go in a for loop, and we're going to say, do you have the ambient AI class? Because if you're tagged with AI and you don't have that, that's a problem. But it's always good to... to fail forward is a good example. Like if you're going to screw up, you might as well screw up gracefully and not completely fall apart. And that's kind of what this does. It just makes sure that you check for it. If that's fine. If it has it, then we're going to act accordingly. If it doesn't, we're just going to ignore that it doesn't and move on. And then if it does have it, then we're going to store that in a temporary variable so that we can access and do some checks. We're going to see if that alignment is the same as our alignment, and if it's not us, because we don't want to store us in our ally list. This AI, the AI that I made for this, doesn't actually use the ally list. I thought it would be an interesting way to like set up stuff for the future. So like you could essentially springboard off of having an AI list to make certain AI go and heal other AI, for example. So if you wanted to have like a cleric class, eventually he would need to know where all of his allies are so he can, run over to one and heal him if he needs to. But in this particular system, I wanted the groundwork for that to be done, which is, it's just another list of stuff and I'm already sorting the list, so I might as well sort this too. And that's kind of why I did that. There's also another thing that I didn't think about where, okay, well, let me finish what I'm saying here. So if the AI's alignment is equal to our alignment and it's not us, because we don't want to be in the ally list, then add it to the ally list. And I'll talk about what that does in a second. Now, if it's not us, then add it to the enemy list. So essentially what I'm saying is, if the alignment is equal to ours, then it's an ally. If it's not, then it's an enemy. So it's kind of a Boolean kind of thing here. I don't have any gray area. If you wanted to have a gray area, I was kind of thinking about how that would look. And if you don't need to access your neutral alignments, you can kind of do something like this. If the AI's alignment equals alignment.none, return. And then turn this to an else if. So the idea here being that if the thing that we're looking at doesn't have an alignment, then just ignore it and move on. This is one way to do it. The other way to do it is if you need to access your neutral alignment characters or whatever, then you can filter those into another list like we're doing for these two. Just if this, then add neutral or whatever, and then you have another function for add neutral. Yeah, I mean, it's not terribly complicated, but that's how we're sorting. And then I have some debug information that spits out after that for like who we added and how many we found. Great. So we have this add ally and add enemy things. What are those? Well, they're basically the exact same function, and I could do this a better way if I wanted to, where I could just say add to list and then have the list that I feed in. Actually, you know what? As a matter of fact, I'm going to do that. I'm absolutely going to do that. So you get to see a little bit of on-the-fly coding here. So the way that we're going to do that is we're going to add an enemy, we're going to feed it the enemy's list and our temp. And if we're going to be adding an ally, we're going to feed it our allies list here, and our temp. Now, again, the allies and enemies list is just a private ambient AI list that we have declared up here in the ambient AI class. So it's not, I mean, it's basically, these are lists of this thing. There are lists of what they are housed in, so that we can store things like, so we can store other AI classes in this and not, and be able to access them in a way that makes sense, and we don't have to type out a crap load of stuff to do that. Anyway, so yeah, we feed in that list, and then we feed in what we want to add to it. And we're going to say add to list. And then we're going to, for the purpose of this, I'm going to copy this whole thing. I'm going to paste it, and then I'm going to say this is add to list. And then I'm going to say that there is an ambient AI list. Say, call this list. And then we have our to add. So this list is going to replace, in my thing, it's going to replace that. And I think that's it. I'm pretty sure that that's all I had to do. Alright, cool. So I can delete these now. And I can kind of explain why that is and why that is the way it is and why I did that. I'm going to double check really quick that I don't have any errors. Boom, and I don't. Cool. So what I'm doing with add to list, this new function that I created, I am looking at a list of, hang on, list, not length. Perfect. Okay. And I need to change this to list. List. Okay, cool. Sorry. So what I'm doing is I am creating I think I've talked about this in previous videos, but I'm just adding something to an array. So I am creating a temporary list that is one longer than the current list that we have, right here. This is what this says right here. And the reason why I'm doing this is we're adding something to it, so we have to make the list be able to encompass it. Then I'm going through that list, and I'm setting each slot to what we already have, and then at the end of that, I'm slotting in the thing that we're adding, and then I'm setting the old list to the new list. So kind of like I am with the whole drawers example from the array video. I am building a new dresser with one extra drawer. I'm moving everything from the old dresser to the new dresser, and then I am throwing the old dresser away and replacing it with the new one. It's kind of the convoluted way of doing that, but that's how programmer stuff works. Anyway, so that's gathering targets, is we're just slotting the things that we need into the lists that we need them to be in, and then we can go right back up to start. Great, so that's the end of start, and then we go into update. Update is where we start to get into some hairy stuff. That's where we start getting into state changes and how to discern what's happening with those states. I tried to make it as simple as I could and doing it the best way that I could. So I'm just going to kind of start in. The first thing we're going to do, and this is kind of these first 4 lines of code are inexcusably brute forcey, but they work for the purposes of this example so that I didn't have to do anything overly complicated for something simple, so I could just keep moving. If our current state is not flee, and our health, a percentage of our health, which is what this returns, right? Like, I'm multiplying it by 1.0f so that I get a float, but I'm just dividing the current health by the base health, and that gives me a percentage of the health that I have. Yeah, the how much health I have left. If that is less than our flee percentage, our health flee percentage, and we have a target, that's what this last part says. If perception info.target is not null, so if we're not fleeing, but we should be fleeing, and we have someone to flee from, flee. That's all this is saying. The brute forcey thing about this that I don't like is that it's checking this every frame, which, I mean, maybe that's a good thing. Maybe I feel like that's a bad thing. It feels not right, but it works for what I'm doing. So yeah, hopefully that makes sense. The next thing that we're doing is kind of a similar thing. We're checking if our current state is flee, and if it is, then, and we're not running at the correct speed, if we're not running at our flee speed, but when we should be, then set it to the flee speed. And then vice versa. If we're not fleeing and we're using our flee speed, then stop using our flee speed. These are just two things that I start off update every frame. I'm like, hey, check these things out, because sometimes I don't have a system to properly set them the way that I probably should. But this kind of thing, I mean, it's not an expensive call to make, so I don't feel terribly bad about it. I mean, it works for what I'm doing, but it's not like the best practices. Your scripts could always be better is my mentality, and it's two mistakes that aren't really mistakes. It's problems, not mistakes, I guess. I don't know. Anyway, so now we get into the meat of the AI, which are these 4 lines, believe it or not. We're checking our current state against a state, and we're saying, hey, if you are this state, then do this thing. If we should be wandering, then wander. If we should be fleeing, then flee. If we should be investigating, then investigate. And if we should be attacking, then pursue. That's the only one that's weird, right? There's a reason why. Because labeling the function attack would have been not a good term for it, and labeling the state pursue would also not be a good term for it. We can talk about that in a minute. Let's go ahead and start with wander and see what there is to see, because it's right here. Wander is pretty straightforward. Basically what we're doing is we are getting we're sampling a position on the nav mesh. We're sampling our position on the nav mesh, and if we can, using this, sorry, it's been a little while since I've looked at this script. I kind of did a cursory glance over it, but I didn't look at everything, so I'm using this sample position to get the AI's location, since the destination is also a nav mesh location, and they need to equal each other. Right. Okay. So I'm seeing that if we're on the nav mesh for some reason, yeah, that's what I'm doing. I think what I'm doing is I'm saying, hey, I'm basically using this just to set the nav mesh hit variable so that we can use it later on. I don't think I'm actually checking to see if we're on the nav mesh, because technically we should never leave the nav mesh. But anyway, so then I'm seeing if our distance to from our hit position, which is what we used, that's what we set it in this line here with the out hit. I'm seeing if our hit position is less than the stopping distance to our destination. So how the distance from our position to the destination is less than our stopping distance. That's what I wanted to say there. So basically I'm seeing if we're at our destination, as I say right there. If we are, then we're going to want to set our destination wait timer to increment up. We're going to increment that by delta time, the change in time. And if it is more than our destination wait timer, if our destination wait timer is more than our current wait time, then we're going to want to find a new location and then reset the timer and then set our current wait time to a random value between the two ranges that we set up top. So effectively what's happening here is find out where we are, check that position's distance to the destination and see if it's within our stopping radius. And if it is, then start waiting because again we have this system where we go to our wander system is such that we find a random position, we go to it, and we wait there for a random amount of time, and then we move on. So go to that place, wait a random amount of time, set the next time that we're going to randomly wait till, and find a new place to wander off to in the meantime. That's basically what's going on here. So the find new wander destination is actually, it's not terribly complicated. It looks a lot more complicated than it really is, I think. And I think this is one of the things that I ended up overhauling from the last video. So I don't know if I ever showed this or not, but it is different. So I'll talk about what I was doing and what I am doing now, because what I'm doing now is much more graceful and much more simple. So the purpose of this is to return, well, it's to return nothing, I guess, because we're just setting a variable. But basically, it's to create a within a donut shape around our AI. So within a it's hard to describe, but we basically have a minimum radius and a maximum radius, and we want to select something between those two, if that makes sense at all. So sorry. All right, there we go. If we're going to do that, we need we need some information. Anyway, it's gonna it's gonna find a location within that donut of around our character, and it's going to set that as our destination. That's what this does. The thing that we that we feed into it is a bool, and that's if we want to use line of sight or not. So that's, can we see the position that we're trying to go to or not, or do we want to have to see the position that we're going to or not? This is useful for like sometimes if you find a random position, the AI might not be able to travel there because it could be on a different patch of nav mesh. So say like there's a floating island in the middle of a nothingness, but it's close enough to the AI that it can read that position maybe. It won't know how to get there because there is no way for it to get there. So this is that's actually a really bad example because maybe there is nav mesh in an enclosed room. This is a good example. I promise. So if you have 4 walls of an enclosed room, and there's nav mesh on the inside and there's nav mesh on the outside, and your AI is on the inside, and you're trying to get to the outside, you can detect the nav mesh out there, but you can't get there. So this check would tell you that you couldn't get there, and then re-roll your chances to find somewhere else inside of where you are, if that makes sense. So the find new wander destination bool for use LOS is kind of handy, and hopefully that'll make sense when we get down into it. But anyway, so we're going to set our new location to our location. The reason why we're doing that is because if we just set it to vector 3 or vector 3.0 or the origin, which is what it would be defaulted to, then there's a possibility that the default location for the AI to go to would be the world origin, and that wouldn't really be a good thing. Especially for like bigger levels and stuff, that'd be kind of wonky where he just kind of like wanders off, or like a couple of the AI just wander to the center for some reason. It would make the center of the world a more prominent place to visit by the AI, and it would seem less random. Anyway, well, because it would be less random, but that's beside the point. So setting it to the transformed out position of this object so that if it defaults to that, it'll immediately just wait and then find a new position. So the system will handle it gracefully instead of just picking a place that I don't want it to go. And then this is just our bool for if our location is valid or not, which we will, which we used a couple places, like for example in this for loop. So I run this 10 times, and this is kind of like a fallback. So there's a reason why I do this. I want to run the for loop for as long as location valid is false. The problem is I may never be able to find a valid location. So if I just left this part out like this, then there's a theory, well, theoretically, this script could freeze and crash the game because it would never actually terminate. If the AI can't find a valid location around it, for an indefinite amount of time, then the game crashes. That's not good. So I set a 10 chance limit. It'll try 10 times, and then it'll just cycle a frame. So in other words, it'll try 10 times a frame to find a place if it can't, which is going to be pretty unlikely. It should find a place after like the first or second try at the very, very least. Or very most, I guess. Anyway, you get what I'm trying to say. So what we need to do is we need to generate a vector 3 within that donut. So the easy way to do this, that I have found at least, is to generate a random value, a random vector 3, and it goes without. It needs to be mentioned that I'm fitting 0 in for the y because I'm assuming this whole thing is going to take place on a 2-dimensional plane. So the first value is going to be our wander min max, and the third value is going to be our wander min max, and random range between those two. The reason why I'm doing it this way, the reason why I'm doing it this way is interesting. This is going to create a positive value and a positive value. In other words, it's going to create a value somewhere inside of a radius up here, right? Like it'll create a radius up to here, over to here, and that's it. That 1/4 of a circle. The reason why this is okay, though, is because of this line down here. I say there's a 50-50 shot for me to multiply the x by -1. And there's a 50-50 shot for me to multiply the z by -1. So effectively what I'm saying is I'm generating a range between our min and our max, and then I'm saying maybe that'll be negative, maybe it won't, I don't know. And that awards equal opportunities to all 4 sectors of that circle, of that donut. The way that I was doing it before was I was attempting to do all of this in one line. So I was trying to do all of that inside of this random, or I was trying to multiply the random range by like 0.5 and then multiply it by something. I was trying to do some weird crazy equation to each one of these, and this just ended up being so much more graceful and easy. I don't know why I was not thinking to do this, and it works too, which is awesome. Anyway, so that creates our vector 3. These 3 lines of code create our vector 3 within our donut, and then we're gonna offset that by our position, because again, this isn't actually creating the position on us, it's creating the position on the world origin. So we need to offset that position to us, and then it'll be usable for picking our location around us instead of just around the origin. So we need to create the ray cast hit if we're going to be using the line of sight. And we're going to do a line cast to that position. And if we can see it and we're using line of sight, basically, if we can see it and we are using line of sight, then our location is valid. And by can see it, I mean it doesn't hit something in the way. Again, line of sight checks are kind of backwards from how you expect if you're using them. Line of sight checks are backwards from what you'd expect, but raycast checks are always forward from what you'd expect. So like, hey, did I hit this? As opposed to, hey, did I see something? It's kind of weird. Anyway, and if we're not using line of sight, then our location is perfectly valid. So the only time that the location valid would ever cause a problem is if we were using line of sight. So line of sight is technically a little more expensive in that way because it runs a physics check and it can run the physics check multiple times. But sometimes it's worthwhile. I don't know. It's useful. And then if our location is valid, then we're going to set our new location to our test location, which again, new location is up here. Test location was what we created here when we generated a new vector 3. That's just making sure that we set that for future use. And then we say, hey, if the location is valid, then we're going to find where that location is on the nav mesh. Because that's important, because we're moving on the nav mesh. Not just in arbitrary points of space, which is, I know, it's weird. So we're going to sample the position on the nav mesh, and we're going to say, hey, cool, you found it. Here it is. Or we're going to say, holy crap, no nav mesh in that radius, and we're not going to move our AI at all. So this right here, this one line is what determines where we move to. Everything else is figuring out where that position is, but this is going to set that destination for us. And that is creating the wander state. I'm going to go over one more state, and then I'm going to call it quits for this video, and I'm going to pick it up in a part 3, I guess. Jeez. But yeah, so let's talk about flee really quick, and then I will call it quits. Flee is actually really, really easy, so maybe I'll talk about flee and investigate because they're both really simple. Okay, cool. So flee. Basically, the gist of flee is run from your current target. And we already kind of talked about up here this is half of flee already. It already happens every frame, which is check to see if you should be fleeing still, and check to make sure that you're running at the correct speed. So perception info, if okay, people outside. If the perception info current target is null, or if our current target is not null, and we're far enough away from them that we don't care, which is what this ungodly, horrible crap line is here. It's mostly because of the perception info.current target.transform.position. That's all one vector 3 name, so it's kind of long. But anyway, basically, if we don't have a target, or if our target is far enough away from us that we shouldn't care about him, then we should not be fleeing. And we should be setting our current target to null in that instance because we don't have one. If we have a current target, we should no longer have one because it means he's out of range of our detection. Yeah, that's all that's saying. And then after that, we say, hey, if you don't have a target, also perception info target does not equal no. Sorry. It's also late, and I worked a full day today, so forgive me if I'm a little foggy. So if we do have a target, and we're not fleeing anymore, then we want to discern a direction away from that AI. So we're going to normalize the two positions, so our position minus their position, and we're going to get a vector going away from them in a line. So like draw a line from them to me and then run in that direction, if that makes sense at all. So basically away from them. And then we're going to set that as a position, and we're going to set that as our destination. So this is a direction, and then this is a position, and then this is our destination, which is kind of a weird way to talk about fleeing because you'd assume we could just tell it to run. But unfortunately, we can't. There's a reason why. This also isn't a perfect system either because we get stuck in corners with the system. This is actually like the simplest flee script probably in existence. It's really stupid and dumb. It's like, hey, run from the thing behind you, cool, good, done. And really what should happen is run from the thing behind you unless you can't run forward, then turn left. Like, it should have some sort of complexity to it, and it just doesn't. For the purposes of this example, I thought this would get the ball rolling at least with you guys. So yeah, set the destination to our flee position, which is away from the thing we're running from. And yeah, that's flee. So that covers that one. That covers wander and flee, and now we're going to look at investigate. So the idea behind investigate is once we have run out of... it's kind of like it's tied to attack is what it's tied to. So if something is in our perception range but not in yeah, and like I'm saying here, I think there's a bug somewhere in that for some reason the AI never seems to look around as I expect them to, and I'm not sure what's going on. I tried investigating into this and I couldn't really figure it out, but in theory the idea is that if an AI makes line of sight to something, it will go to the position that the thing is at and look around for where it is. So the idea being that if when an AI can see another AI, it's constantly tracking its position, and if the AI that it is tracking gets out of its line of sight before it can get to that position, it will investigate the last position that it saw it at. So the best way to explain this is, visually, is this AI down here sees this AI, and then this AI runs around the corner, And this one doesn't know where it is anymore. So it runs to where it saw it last, which is here, and it'll do a little investigate thing where it like it goes to this position and then it looks left, it looks right more, it looks left, and then it looks left again, and it like randomly looks around, and then it goes, I don't know where it went, and then it starts wandering away, and then eventually it'll see it again, is the theory. So anyway, that's what I expect to happen, at least. That's not always what happens. Sometimes it happens, sometimes it doesn't. But basically the only thing that is bugged with this is that they don't look around. And if someone in the comments, by the way, wants to go ahead and tell me what I did wrong, great. Because you're not telling just me, you're telling everyone else who watches the video too. So, again, the only best thing we can do is educate each other, right? That's why I made this whole channel. So, so the first thing we're going to do is check our distance. If our distance is greater than the distance between us and them is greater than our search radius, then we're going to enable our investigation state. That seems kind of counterintuitive because we've already entered our investigate state, right? Sort of. We haven't actually done anything to initialize the investigate state yet, is kind of what I'm saying. So if this is the case, this is more or less just like a, there's an investigate and a search state, but the search state is part of the investigation state. I'm doing a really bad job of like defining which state is which, and I probably should have made investigation a separate state that has like a heightened search radius or whatever, but I didn't. So effectively what I'm doing here is I'm saying that this is the investigation state, and then this is the search state down here. It's not a good way to do things. Anyway, so if the distance to the last known position and our destination is greater than the search radius, so if we've arrived at where we are, then we have entered into our search state, our investigation state, and that's all I'm doing here is I'm just saying, hey, record the look destination. So like make a new, our look destination is where we're currently looking, our current Y rotation, which is a really bad way to do it, and then set the investigation timer to 0, and then start going into here. So if the distance is less than, the distance between us and our destination is less than the investigation distance, then we're going to start like looking around. We're going to say, hey, wait, what? If, oh, right. This is just like a weird check that I did. So like, I had a mentality here when I was doing this. My designery, I've said this 1,000 times. I'm a game designer. I'm not a programmer. So a lot of the time my designer senses creep into my programming, which is a good thing, arguably. And this is one of those things. I wanted it to be such that they got to a certain distance away from where they were last. So they didn't go to the exact position where they saw them last. They just got close enough, and they were like, all right, where did he go? And I don't know, to me that just feels a little more organic instead of like going to the exact spot that you saw them last, which can be kind of weird looking. You just get to you get close enough, and I'm essentially allowing for failure in the AI purposefully. So once you get within a certain distance, stop, and then set where you thought you saw them to where you are, if that makes sense. So I'm saying that the AI purposefully makes mistakes every time it searches for something, because it never quite searches exactly where it needs to, and I find that really interesting. I wish I would have made it a little more random to make it a little more interesting, but I didn't. So so that's what this line does here, is it just like, I'm within a certain radius, and then I set that position to my position. Anyway, then we're going to start ticking our timer, and this timer is basically going to be how long are we investigating. Yeah, that's all this does. And then once we're done investigating, then we're going to go to wander if we don't find anything. Because if we find anything, we're going to automatically switch states. That happens down in pursue, I believe. Or no, that happens in check LOS. Check LOS is by far the most complicated function that I have in this entire thing. It is scary. So, not to hype it too much, but, I mean, I'll talk about it eventually. Just not in this video. In the next one, probably. So anyway, take our investigation timer up, and once we're done investigating, if we didn't find anything, then go to wander. And then, otherwise, if our investigation timer is less than or equal to, if if we're not done investigating, then we're going to do this whole look around thing. And this is the part that's broken, I think. I'm trying to do a Quaternion.lerp to rotate my character around, the AI around, and I should be doing it in a better way. I should be doing it with a look at, for like looking at random locations around them. But I'm not, and I should be, and it's a travesty. But so yeah, the look around timer goes up, and when it goes over the look around change, then I take the timer. I've done this 1,000 times, and then I get a new random range between 0 and 360 because that's angles. That's how that works. That's a circle. So then I try to set the Y rotation by transforming it into Euler. All this is really complicated too. That's probably why it's so failure-y, is because it's overly complicated. But I'm essentially lerping to a random y-axis rotation. So I'm saying, hey, find a new rotation between 0 and 360. That's up here, and then go to that angle on your y. That's all I'm doing here. So Quaternion.Euler vector 3 look dest in the y, and 0 0 in the others, and then multiplying that by the look around speed by delta time. The speed is the delta time multiplied by the look around speed. Yeah. So, but none of this is working, and the better way to go about this would be just to generate use our same function for gathering a random position in our donut, and then telling it to look at that position. That would be the most graceful way to handle this, and I'm not doing it that way. There's a problem with doing it that way, though, I think, in that there is no way to smooth that motion out that I can think of immediately. So I would have to... oh, is there a turn toward? Transformed... Oh... There is a way to make things turn towards something else, and it's over time and it's smoothed, but yeah. So again, comments, yell at me, tell me I'm wrong, and tell other people that they're how to do it. But basically, I think that the best way to do it would just be to find a vector 3 and then look at that position. You could use a look at the transform.look at. Look at this one, but the problem with that is that it's going to snap the rotation to that position instead of smoothly turning to look at it, which is what I wanted. Granted, you could have kind of a comedic feel with it, like snapping and looking and darting around, but I chose not to do it that way. Yeah, so that is investigate. So I believe the next one that we have is flee. Or pursue, sorry. But being the video is already at around 45 minutes, I'm going to leave it at that, and I'm going to pick up where I left off on the last one, and I'll go over pursue, check line of sight, and this weird thing I have at the bottom for health regeneration in the next video. Also, pursuing is going to handle how damage is dealt and received and all that jazz too. So between this and this, you will know how to do damage in AI. It'll be fun. Check line of sight is a meaty thing, and I hate having to explain it because all of this is line of sight. So like from here, from line 242 all the way down to line 310 is line of sight checks, and it's kind of nasty, and I messed up really bad last time, but I fixed it and it's good now, and I'm so happy. Anyway, so yeah, I hope that was helpful, and I hope that I will be able to produce another video soon on this last part of the AI journey that we've been on for far too long, because I'm inexcusably irresponsible with making videos. Excuse me. I apologize for that, and hopefully the next video will be out soon. I hope this was helpful, and bye-bye!